World War II wasn't just fought with rifles, tanks and maps. It was fought in freezing forests, flooded fields and windswept plains where, honestly, warmth meant survival. In winter campaigns, from the Ardennes to the Russian front, the cold became a weapon deadlier than artillery. Supply lines failed. Fuel ran out. Standard-issue stoves barely heated a tent, let alone a forward camp. Yet, in these bleak moments, soldiers began relying on an improvised heating technique that military engineers quietly documented because of how shockingly effective it was. It wasn't elegant, it wasn't regulation, and, well, it didn't require proper fuel. Instead, it turned worthless scraps, oil cans, axle grease, spilled fuel, damp wood, charred cloth, into a heating system capable of warming dugouts, barracks and entire tent groups. Some units called it the chimney can. Others called it the drip stove. In field manuals, it eventually became known as the improvised oil drip heater. Whatever name it carried, it earned a legendary reputation because it produced stable heat for hours, often on fuel sources too poor to burn in anything else. And now we break down exactly how this World War II stove hack worked, why it outperformed standard stoves, and how anyone today can apply the principle safely and effectively. The hack relied on controlled fuel dripping rather than open burning. The brilliance of the World War II oil drip stove was its ability to create clean, sustained heat without the roar or waste of a normal fire. Instead of burning fuel all at once, soldiers built a setup that allowed oil or fuel to drip slowly onto a hot metal surface. Once the surface reached operating temperature, each drop vaporized instantly, producing steady flames that required almost no tending. This delivered a surprising amount of heat from minimal resources. Some versions used a flattened ration can as the burner plate. Others used the bottom of a cut-down jerry can. The fuel tank was usually a punctured can, suspended above it with a rag-stuffed inlet to regulate flow. Because the stove burned vapour and not liquid, it stretched whatever the soldiers could scrounge. Motor oil, leftover fuel, salvage grease or stove drippings into a long-lasting heat source. Soldiers built these stoves from junk because, well, the geometry mattered more than the materials. In the field, standard materials rarely survived the march. What soldiers did have plenty of were ruined cans, food tins, broken tools and scrap sheet metal. The oil drip stove was designed perfectly for these conditions. As long as you had a metal container for the burner, something to act as a reservoir and a way to suspend one above the other, you could create a functioning heater. Units in Italy used olive oil tins. Troops on the Eastern Front used artillery shell casings. Pacific Island regiments sometimes used fuel drums cut into small sections. The success of the system had nothing to do with material quality and everything to do with the flow control and heat distribution. The stove heated entire camps because it burned slow, hot and efficiently. What made this hack truly stand out was its ability to heat more than just a small space. When placed in a dugout or a tent group with proper ventilation, The oil drip stove radiated heat outward consistently, instead of spiking and dying like a wood fire. Soldiers often added simple chimneys made from nested cans or lengths of pipe to distribute heat better and vent smoke safely. Units stationed in Norway and Finland, well, they became masters of this, building stoves that ran through entire nights with barely a pint of fuel. Their tents became warm enough to dry wool clothing, something nearly impossible in Arctic campaigns. Mechanics in motor pools often built larger versions to keep tools warm and prevent engines from freezing solid during night shifts. For practical modern use, the World War II drip stove principle can be adapted with better safety and, well, precision. A simple version starts with a metal container such as a small paint can or a heavy steel pot. This becomes the combustion plate. Above it you suspend a small metal container with a tiny pinhole or, an adjustable valve to control fuel flow. Fill it with lamp oil or diesel, never gasoline, and allow the fuel to drip slowly onto the preheated plate. Once operational, the stove produces stable blue-yellow flames and gives off significant radiant heat. A homestead application is heating a small workshop or greenhouse. Because the stove burns fuel slowly, it stretches resources and reduces the need to constantly add wood. Farmers in remote areas have used this method for decades to keep outbuildings warm without expensive kerosene heaters. Another example is emergency cold weather sheltering. In a survival situation, a scaled-down drip stove paired with a makeshift flue pipe can turn a small snow shelter, dugout or tarp structure into livable quarters. The key is careful ventilation and slow fuel flow. This mirrors exactly how World War II soldiers operated these stoves to avoid smoke buildup and excessive flame. A third example is long-duration camp heating. While most wood stoves require constant feeding, a drip stove can run unattended for longer periods as long as the fuel is regulated. For winter camping groups, this offers a way to keep a shelter warm through the night without waking someone up every hour to stoke the fire. Understanding this stove hack, well, it really shows how World War II soldiers relied on engineering logic, not just luck. You see, many wartime innovations actually came from desperation. But the drip stove wasn't just a field improvisation. It was a direct application of fuel-air combustion principles, the sort that were taught in engineering units. The fact that frontline soldiers could recreate it with whatever metal scraps they had, well, it just shows how deeply the knowledge spread. When tents blew down, when rations froze, when standard stoves clogged or failed, this hack became the one heating method that always worked. It heated hospitals. It heated command posts. It heated listening stations. It heated entire forest camps in winter offensives where every other heat source failed. It is honestly one of the most practical pieces of forgotten World War II fieldcraft. If you want more historical field techniques, forgotten tools, and wartime survival knowledge that still works today, make sure to subscribe, share this video, and help keep these powerful lessons alive for future explorers, reenactors, and builders.